Hi guys, my name is Jisun Kim. In this video, I'll be discussing about application of derivatives, specifically on motion.
Before we begin with our problem, let me discuss some important things about derivatives. First, what is derivatives? Derivatives can be approached in two different ways. One is geometrical as a slope of a curve, and the other one is physical as a rate of change. It is an expression representing rate of change of a function with respect to an independent variable. Where can you apply derivatives? We can apply derivatives to measure velocity and acceleration, to find marginal analysis, and to calculate rate of change. And why do we need to study derivatives? As we study and learn derivatives, we can use these properties to study movements. For example, we can measure our car if we know its velocity and at any instant, which is something doable. Another implementation is using in chemistry. It can be used when you want to find the concentration of an element in a product. Like this, studying derivatives can be applied in many ways. Next, why do we need to study derivatives? As we study and learn derivatives, we can use these properties to study movements. For example, we can measure our car if we know its velocity at any instant, which is something doable. Another implementation is using in chemistry. It can be used when you want to find the concentration of an element in a product. Like this, studying the derivatives can be applied in many ways. Lastly, what mathematical skills are needed in order to solve derivative problems correctly and more efficiently? The needed mathematical skill for us to solve derivative problems correctly, we need to know these important rules. First is using of definition, which is involved in calculating limits. Next, the chain rule. With this, you will be able to find the derivatives of almost any function. Third, the product rule. This allows you to find derivatives of functions that are products of other functions. Next is the quotient rule. It is a special case of product rule. Lastly, implicit differentiation. It allows you to find derivatives of functions expressed in a funny way that we call implicit. The key is understanding the chain rule. Now, let's go to our problem. A pebble dropped into a compound causes ripple in the form of concentric circle. The radius of R of the outer ripples is increasing at the rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the disturbed water changing? So first, we write the given radius, which is the rate of the increase of the radius, is 1 foot per second, which is also dr over dt. dA over dr is 2 pi r because it came from the derivative of the formula for the area of circle, which is pi r squared. We already have dr over dt and dA over dr. Having these two, we can now find dA over dt, which is the rate of increase of the area of the disturbed water changing with the given radius 4 feet. Substitute 4 feet to the radius to find dA over dt when radius is 4 feet. So the total area for the disturbed water changing is 8 pi feet squared per second. So this is all for my tutorial video. Thank you for watching my video.